Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face Trending List, published on November 27, 2025, about 4 days ago. It shows that by adding explicit thinking and reflection steps to an image editing model, the authors boost performance by roughly 4% on IMG-Edit, 5% on G-Edit, and 8% on CRIS. The paper is titled, REASONEDIT, Towards Reasoning-Enhanced Image Editing Models. And as we will see later, this simple reasoning loop has surprisingly large effects on how reliably models follow complex editing instructions. On Hugging Face, you'll find the Step 1 X-Edit version, 1P2 reasoning-based image editing checkpoints, plus diffusers and transformers code snippets showing how to run thinking and reflection modes. Figure 1 shows that adding explicit thinking and reflection steps steadily boosts editing scores across 3 benchmarks. Thinking means the language model rewrites vague user instructions into concrete, step-by-step editing commands. Reflection then inspects the edited image, compares it to the goal, and issues a fix or a stop signal. Across both backbone editors, the blue thinking bars beat the yellow base model, and the red thinking plus reflection bars come out best overall. Figure 2 shows what thinking and reflection actually look like during editing. The top strip demonstrates thinking, where a vague request, like making desertification control effective, becomes a precise instruction to replace sandy ground with green grass while keeping the hills and sky. The bottom strip illustrates reflection, which compares an imperfect phone advertisement image to the detailed brief, explains what is wrong, then issues a refined instruction that yields a successful final design. Together, these panels make the reasoning loop concrete and intuitive. Figure 3 explains how the full thinking, editing, and reflection loop actually runs during inference. The left block shows the thinking stage, where the unified fine-tuned multimodal language model rewrites the original instruction into a concrete editing command before the diffusion transformer generates the first image. The center block illustrates reflection round 1, which inspects that result and issues a refined instruction for generation round 2. The right block details reflection round 2, where the model repeatedly scores image text consistency and finally outputs a success signal once the edited image fully matches the target description. Figure 4 compares how different editors change images when they receive the same natural language instruction, which lets us visually judge how well each model really follows the request. Qualitative evaluation here means human style, side-by-side inspection instead of just numeric scores. Each row shows one instruction, such as changing the animal or fixing a strange car door, and each column shows a different model's attempt. The rightmost REASONEDIT versions most consistently match the written instructions while keeping backgrounds and details intact, so they look both more faithful and more realistic. Table 1 shows that adding thinking and reflection turns the base editors into some of the strongest open-source image editing systems. The table reports scores on 3 benchmarks that test basic editing, real-world knowledge, and multi-step reasoning. The yellow block near the bottom highlights that REASONEDIT S and REASONEDIT Q consistently beat their own base models by several points. These gains mean the reasoning loop is not just cosmetic, because it reliably improves both fidelity and knowledge-sensitive edits. Table 3 shows that both thinking and reflection add clear value to the editor. The baseline without either reasoning step scores about 56 overall on the CRIS benchmark, while adding only thinking lifts this to about 59. Adding only reflection performs slightly better. The full model that includes both thinking and reflection reaches about 61 overall, which means understanding the instruction and then correcting mistakes work together to give the strongest knowledge-driven edits. Alright, wrapping up, 2 takeaways stand out. Explicit thinking and reflection steps make image editors far better at following messy, real-world instructions, and jointly tuning the multimodal language model with the diffusion transformer really matters for reliability. This points toward future vision systems that plan, check, and self-correct. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.